In order to begin this discussion, I'm going to read from Richard Hoagland's The Monuments of Mars, A City on the Edge of Forever, from his Chapter 7, pages 124 to 127. The Martians, by the simplest application of the basic law of physics, thermodynamics, couldn't have evolved beyond the stage of one-cell organisms, even in the entire lifetime of the solar system. Yet, if the face and pyramids were real, then someone, who we would undoubtedly call the Martians, had created on that planet a complex of extraordinary majesty and wonder, perhaps with a technology and scope that dwarfed the whole history of life on Earth, and then used it for some time. Who and why? And now, from where? Suddenly, an entire galaxy of possibilities opened up before me, no longer constrained by the unconscious need to fit the presence of a set of artifacts to a timescale of an indigenous Martian evolution, because one simply couldn't. I realized that even the provisional solstice dating of the face and pyramids at 500,000 years was merely an attempt to make the data fit with some known and understandable reference point. In this case, the fact that on Earth, circa 500,000 years ago, our distant ancestor Homo erectus had been taming fire. But who was to say that the ineffable monuments of Mars were that young? Now that there was no way to imagine a conceivable Martian origin or evolution from whoever made them, not parallel Egyptian Martians, and certainly not the suspended animation creatures of the honeycomb. The alignment data from which I derive my provisional estimate of age on the objects at Cydonia also worked with impeccable geometrical precision every million years, back through a nearly unending regression of obliquity cycles, almost to the origin of the entire planet. The fact that these calculations couldn't be extended before that point was the consequence of an event in ancient Martian history termed the Tharsis Uplift, which had rearranged countless gigatons of planetary stuff within the mantle, and thus had changed the very Martian spin, and its response to outside forces such as tides from Jupiter, which drove the obliquity variations. But subsequent to that event, nothing had occurred to disturb the inexorable rhythm of planetary nodding, so Ward's calculations indicate from some 2.5 billion years, or the resulting summer solstice sunrises occurred at Cydonia in their million-year appearances over the most inexplicable of monuments. If the astronomy appeared in this key alignment provided no constraint to the basic age of the objects at Cydonia, then what of other methods? The only other method open was the cratering. The area of the single Viking frame encompassing the objects, 35A72, was slightly less than 1,000 miles in area, 1,000 times smaller than the area used for crater counting in the literature. Nonetheless, I decided to apply this tried and true technique to this single Viking frame, for it would give me some rough estimate of the number of craters in this region of the planet, and thus a rough idea of the underlying landscape age. And moments later I was presented with a paradox. There are too many craters. The curves published in the Martian literature by previous investigators gave approximate calibrations of a landscape's age using crater counts in numbers of craters in excess of 1 kilometer in size per million square kilometers per billion years. Judging by these curves, the 50 by 50 kilometer region of Cydonia presented by the frame should contain roughly 1 kilometer size crater if it was a roughly average age compared to ages for similar regions of so-called fretted terrain listed in the papers. But the actual number of craters in the picture exceeding 1 kilometer in size was 3 to 5 times the number in the published curves. This could be explained by clumping, that is, the numbers were a statistical fluke caused by a flock of secondary craters falling on this particular region of the landscape from another larger impact some distance away, or they could be real. in which case this region of Cydonia was among the oldest on the planet, over 4 billion years in age. The main problem with sampling such a relatively tiny area as in one Viking frame was the statistical uncertainty. Yet, something about the objects in the picture made me think of ways that such age for the landscape could be real. With the magnifying glass, I examined carefully each of the anomalous objects in the image: the pyramids within the city, the pyramid that DiPietro and Molinar had found, and of course the face itself. Not truly until this moment did I notice that there was a smattering of tiny pits on many of them, between the eyes of the face, for instance, and that there were some considerably larger features, such as the apparent 1,000-foot crater on the shaded side of DiPietro and Molinar's remarkable buttressed pyramid southeast of the city. The more I looked, the more it seemed unreasonable that these evidences of impact could have appeared on such small areas as represented by the face and pyramid in only 500,000 years. Could, in fact, the complex be older? Yet, how could I square that with the apparent freshness of the face and some of the pyramids themselves? Then I remembered something that Mike Carr had written on his entire area of Mars, that there appears to be features which have been stripped as if a covering of some kind had been previously deposited, then eroded away. Could the entire city have been buried, then exhumed by the natural forces of erosion? But if so, when? In the last few million years? Or longer? Carr's rough estimate from when the stripping could have taken place across the northern plains of Mars, including this region of the Cydonia, was impressive. Not for several billion years could this fascinating complex at Cydonia be not millions of years old, but literally billions. We had already seen, from at least two totally independent directions, why the very presence of the face was impossible. So why not one more impossibility, if the evidence supported it? This is a quote from Monuments of Mars, Chapter 7, pages 24 to 27, by Richard C. Hoagland. It is amazing to me that the age of the Cydonia Complex could not be restricted or limited to less than between 500,000 years and billions of years, indicating that in essence there is no solid evidence from the spacing of craters and the density of craters to determine the probable age of the Cydonia Complex. One of the major problems is that there appears to be many more craters concentrated in and around the Cydonia plain than is normal for other areas of Mars, and one needs to wonder why. What attracted bolites to that area? Might I suggest that if those who built the Cydonia Complex on Mars were copying an original that was on Earth, and they needed to get the center of the crater at approximately 41 degrees 36 minutes latitude, they would have to do some target practice in order to see how the ground would respond to a bolide, at what size bolide, the speed of the bolide, and whether or not they could target a specific latitude at that point and produce the outsplash apron that they needed in order to duplicate what is present on Earth. Thus, the age might have nothing to do with the density of craters, because they were practice hitting the Cydonia plain in order to get enough statistical data so that they could fire one bolide at the correct spot and not miss, because they couldn't repeat the process. If they hit in the wrong spot, the crater would not be in the correct location, and they couldn't erase it and go back and start again. The following age for the Cydonia I complex on Mars is based on new information. Only if the crater centers were coincident at the time the Cydonia complex on Mars was created will this method work to determine the original age when it was built. The fact that the centers of the craters on Mars and on Earth are so close to one another at approximately 41 degrees 36 minutes latitude does it suggest that this was the original intent of the builders, because they knew that continental drift on Earth would offset these latitudes and give an age for the building of the Cydonia complex on Mars. The center for the crater on Earth is at latitude 41 degrees 36.206 minutes. The center for the latitude on Mars is 41 degrees 35.567 minutes. That difference is approximately 3,888 feet or 118,506 centimeters, or 38 seconds in latitudinal distance. Once I determined this latitudinal distance, I then had to compute the rate of continental drift in a north-south direction for eastern North America. The North American plate had been moving in a 32 degree southwest direction for the last 17 to 18 million years. How do we know this? Based on a series of 9 calderas, or supervolcanic eruptions, over the Yellowstone hotspot, one can follow the path of the North American plate to the southwest in the diagram provided above. These 9 calderas have ages of approximately 16 million years, 15 million years, 12 million years, 10.5 million years, 7 million years, 6.5 million years, 2 million years, 1.3 million years, and 630,000 years ago. Since then, there have been no major supervolcanic eruptions over the Yellowstone hotspot. Instead, the North American plate has stopped moving southwest. The North American plate is now rotating about the Yellowstone hotspot in a counterclockwise direction. We can see that because there have been no subsequent supervolcanic eruptions since 2 million years ago, when the last supervolcanic eruption occurred over the Yellowstone hotspot or plume. In the enlarged diagram, one can see the original Yellowstone caldera from 2 million years ago. It is as large as the previous calderas, but within it there are 2 smaller calderas colored in red that occurred at 1.3 million years and at 630,000 years ago. These smaller red calderas show that the North American plate has not moved significantly over the Yellowstone hotspot, but has stopped moving after 2 million years ago with the beginning of the Pleistocene Ice Age. Western North America had a subduction zone along its entire west coast over 2 million years ago. Then something changed. The area off of California was transformed into a transfer fault, and subduction ceased, even though subduction has continued in the Cascadia segment to the north off of Oregon and Washington. Instead of subduction off of the California coast, we now have a transformed fault called the San Andreas Fault, where northward movement of the Pacific plate and westernmost California is approximately 3 centimeters per year, and movement along eastern California and the southwest is approximately 2 centimeters per year to the south, with a combined offset on the San Andreas of approximately 5 centimeters per year. The North American continent has changed its movement from a southwest direction to a south direction on the west coast and a north direction on the east coast, with the North American plate rotating about the Yellowstone hotspot where rotational motion is taking place. The lack of physical movement of the North American plate over the Yellowstone hotspot means the caprock over the magma chamber was now highly fractured. This fractured caprock is what allows the gases from the underlying magma chamber, when it builds again, to escape and produce the hot springs that we know as Yellowstone National Park. After the 2 million year eruption, which created the width of the Yellowstone caldera, only minor eruptions have occurred. The rock was so badly fractured on top of the original magma chambers that subsequently developed that gases in them could never build up enough pressure to cause a supervolcanic eruption, and instead leaked out to create the Yellowstone hot springs. The amount of northward movement of New York would be no more than the amount of southward movement along the west coast, or about 2 centimeters per year, and it could be as little as 1 centimeter per year. What do these spreading rates give us for the age of the Cydonia complex on Mars?
At the time the Cydonia Complex on Mars was created, both Cydonia I on Earth and II on Mars, the craters were located at the very same latitude. Since then, the Cydonia II on Earth has moved north by approximately 3,888 feet, or 118,506 centimeters. If the rate of movement north was an average of 2 centimeters per year, the age of the Cydonia I on Mars would be 59,253 years, or in the middle of the last glacial advance. If the rate of movement north was only half that, or 1 centimeter per year, the age of the Cydonia I on Mars would be 118,506 years, or occur just before the end of the Sangamonian or Eemian interglacial period and the beginning of the Wisconsinan Ice Age. When compared to the work of Mark Carlotto in his book Before Atlantis, it appears that there were many civilizations or city-states that existed during the last ice age, and it's possible that any one of them could be a holdover or remnant from the previous world civilization that had existed during the previous Eemian or Sangamonian interglacial. And thus we have a range of possible suspect civilizations that could have created the Cydonia Complex on Mars before the end of the last ice age.